Okay, so for homework last night, all of you did a tutorial on regression. So can somebody tell me what that word means, regression?
Brandon?
So regression is when we try to create some sort of equation to make a prediction.
Exactly. Regression is fitting a line to data so that you can make a prediction. Okay, so what we're going to do today is an activity where you're going to collect data, and then you're going to fit a line, and then you're going to make a prediction. Okay, so I've already handed out the description of the activity. I'd like you to take a few minutes and read the first few paragraphs so that you all know what's going on. While you're doing that, I'm going to hand out some materials. Okay, so the first thing that I want you to do is break up into 2 groups. There are 6 of you, so we should have 2 groups of 3. In each of your groups, you're going to have different tasks for each person. One person is going to hold the yardstick, one person is going to drop the ball, and one person is going to measure how high the ball rebounded. And if there were 4 people in the group, the 4th person would record, but since there are only 3 people, you will all have to figure out who's the most efficient person to record. Maybe you all 3 record. So you'll notice that the assignment asks you to do some practice drops before you gather data. Does anybody know why you would want to do a practice drop?
Try to develop consistency?
Yeah, we want to make sure that we're all measuring the same thing, right? Okay, so the other thing that you're going to want to do is drop from different heights. Why are you going to drop the ball from different heights?
So
to see the rebound properly and do something with the height.
Right. If you always dropped from the same height, then you wouldn't be able to predict what happened at heights other than the one that you dropped from, right? Right. You would have really good data for that height, though. It's also asking you to drop several times from the same height. That's partly because it's a yardstick and there just aren't that many heights to drop from, and also partly because that's going to give us a measurement of variation within just that same height group. So for each height, you're going to drop the ball 3 times from that height, and you're going to have 10 different heights. Okay? Does everybody have a good idea of what the activity is? Okay. There are ping pong balls and racquet balls. Pick one. You don't do both. Just pick one for your group. And go ahead and start gathering some data.
Okay. I want to hold the stick.
So you're going to read? Okay, so let's start.
Yeah. We're going to do it on the table.
yeah, I think that is it.
Did you get it?
So
Wait, let me
which one?
When it
Did
bounces,
you measure
when it bounces
the first
back.
bounce?
Yeah,
Which
like
the
if you-
first bounce?
You're going to measure the first rebound from the
You're going to be looking for the height reach.
counts for.
This is where it's going
Well,
to
we're just practicing, so like,
Yeah, like number 18.
I guess I'll
About
maybe right from the
13
center.
and a half.
It goes higher,
This is
man.
at 35 because it's in the center.
Yeah.
See?
About 14, yeah,
Line up with a
14.7.
pen. There we go.
About 14.7.
Would
Yeah.
it be 7?
Would it be
Sure.
easier for you to look at the top of it?
What about if
We're
you go
supposed to
higher?
measure where the
Yeah, so
ball
this pick
is.
the drop height.
The first bounce.
So let's
The
start
first
at
rebound height.
Yeah, so
What
when
about
it goes
if you
down and
drop
comes
that
up.
from much
Just the
higher?
first
Yeah, and where the bottom of the ball is.
So we should be looking at the
So
bottom.
start like
this one, so then this would be a
35.
I think we are.
Let's start from.
All right, guys, if you've already finished, start entering your data into your calculator, which you learned how to do last night. But just as a review, you're going to hit the Stat button and then go over to Edit. If you need to clear out a list, highlight it, hit Clear, and then Enter. Are you done too? Okay, so we're going to enter the data into the calculator. You're going to hit Stat, and then Edit. If you need to clear out lists, highlight the name of it, hit Clear Enter. Do not hit Delete Enter. Now, you only wrote the drop height once, right? But there were 3 rebound heights for each drop height, and that means that each drop height is going to have to be listed 3 times in your list because these are paired data, okay? Okay, go ahead and enter your data in.
X, Y, then we get the same X and match to another Y.
Exactly. You have to make sure that you have them listed as pairs in your list, because if you don't, it won't graph correctly when we make our scatter plot. Which is, of course, the next thing we're going to do is make a scatter plot. If you remember how to do that, you can go ahead and do that. I'm going to wait until everybody's done to tell you how to do it.
This and this, you start from, you start X.
Like, I see what he's
You
saying.
want one scatter plot where
You
the...
just pick one of the rebound height.
No, you should have a total of 30 data points in both lists. So you have 30 values in your X list and 30 values in your Y list. It's just that the X list is going to have repeats in it.
Okay. Did you do
Okay.
that? Or did you put them side by side?
Let me see. I put them side by side. I usually do them like this. You didn't do it like I did?
Plot. You have stat plot there, and now I'm going to borrow your calculator so that I can talk people through it. Turn one of the plots on and highlight when you select that plot, you're going to highlight the scatter plot, which is the first choice under type. And then under X list, you want the list where you put your drop heights from. And under Y list, you want the list that you put your rebound heights in. If you need to change something, let's say that you need to put in an L1, that's a second one to make it an L1. Okay? You can choose whichever mark you'd like. Once you're done with that screen, you're going to go over to Graph, and a lot of times you don't get the right looking graph because the window is off. If that happened to you, then you're going to press Zoom, and you're going to choose the 9th option, which is Zoom Stat, and it will size the window to look at the scatter plot.
Okay.
Okay? So does everybody have the scatter plot?
Yes.
All right, so the first thing that we want to do when we're looking at this graph is ask ourselves, does it look like there is a relationship between the X values and the Y values? Yes. Okay, does it look like that relationship is a linear relationship?
Yes.
It kind of. Okay, so that means that we do think that there is a linear relationship. And by the way, when we think that there is a strong relationship between the variables, there's a vocabulary word for that. Those variables are, starts with a C. Correlated, right. And is this correlation going to be positive or negative?
Positive.
And how do we know that?
Because as
X increases, Y increases.
Right. The slope is going up as X increases, Y increases. So we know that there's going to be a positive correlation. Okay, so now we want to actually figure out what that relationship is. We want to find the line that fits this data. Okay? So when you did your tutorial last night, you turned the diagnostics on. But just to double check, let's make sure that your diagnostics are on. And after you do this, you will not have to ever do this again. So you're going to do, what are you going to do? Right, so you want to select diagnostic on and hit enter, and it should say done. Okay? So that's a one-time thing. You won't have to do that again with this calculator. All right, now you want to go to Stat and arrow over to Calc, And then I think it says linreg AX plus B, the fourth option. You're going to put in L1 comma L2 if you put your x's in L1 and your y's in L2. If you put your x's in L3, then you do L3 comma L2, right? Okay. Then hit enter. Okay, so you should have 4 pieces. Yes, 4 pieces of information on your screen, right? You have an A, a B, an R squared, and an R. Let's start with the R. Does anybody know what that R is?
Linear correlation coefficient.
That's the correlation coefficient. And the fact that it's a positive 0.96 means that the correlation between these variables is positive and large, right? Because 0.96 is really close to 1. So we have a very strong positive correlation. Okay. Did we talk about R squared in the tutorial? Okay, what does R squared mean?
How the data fits.
Coefficient of determination.
I know, it's not fair to you guys because you didn't actually see this tutorial that I'm talking about. Coefficient of determination. And what does it mean?
It's the percent of the variation in y that's explained by x.
Right. And what is it this time? 3.6. So 93%, 94% of the variation in the y variable is explained by variation in the x variable. That's about as strong a relationship as you're ever going to find in a real world situation. Okay, so let's talk about the A and the B. The fact that the calculator gives you the equation y equals ax plus b tells you what A and B are. A is the slope of the linear equation, and B is the intercept of the linear equation. And what we're really interested in here is the slope. Okay? So A is what? 0.66. So that is saying that if x increases by 1, y is going to increase by 0.66. Okay. So what was x?
Rebound.
Drop height. And if I increase x by 1, what am I doing?
Raising it 1 inch.
I'm raising the ball up an inch before I drop it, right?
Yeah.
And what was y?
Rebound.
So an increase of 0.66 in y means the rebound is going to increase by a little over half an inch. Okay, so if the rebound was 12 inches at 24 inches, in other words, when I dropped it from 24 inches, it rebounded 12 inches, which I'm sure is not what it was, but if that was what it was, then when I drop it at 25 inches, what would I expect the rebound to be? 12.6, right? Okay. Everybody's good with the interpretation of the slope? Okay. I'd like you to go through some of the questions in the rest of the handout. They ask you about interpretation of this slope, and I'll go over it in just a few minutes.
That's a pretty.
So we are making a prediction for
Okay.
I think we did
Oh, we did 10.
do 11.
Right? So let's talk about what makes us trust the model and what might make us not trust the model. First of all, you guys had ping pong balls and you guys had racket balls. Do you think your models are going to be the same?
No.
Are they? Compare your model.
No.
Yeah, they're different.
So their slope is much higher than your slope?
Yes, I got 0.7. Yeah.
So what does that mean in terms of the ball?
Ball bounces
bounces much more.
Ball, right? Which actually, that kind of surprises me because I would have thought the racquetball would have been the bouncier ball.
Yeah.
But anyway, so you were saying that your model is not to be trusted for new predictions. Why is that?
We don't have the same person dropping the ball and checking the height. The roles have changed.
Data collection is really important in these models, right? And let's talk about where we spent all the time. So we collected data, we put data in the calculator, we got a model, we made a prediction. Where did all the time go?
Data collection.
In the data collection, right? Where do we spend all of our time in class?
Analysis.
We talk about analysis all the time, but in the real world, where are you going to be spending all your time? In the data collection. And it's really important to have good data, because if we were to use your model to try to predict something based on their ball, that wouldn't be a good idea, right? What else would be a bad idea? For, say we're using your model and your ball, what else would be a bad way to use this for prediction?
Well, you were concerned about using different racquetballs, because one might be more worn out than the other one.
Maybe the racquetballs are different, right?
The heights we're dropping them on.
What height are we going to drop it from, right? So I'm guessing that because I gave you a yardstick that all of your numbers were between 0 and 36, right? So what if I asked you to drop something from a height of 60 inches?
It's not very extravagant.
We can't extrapolate that far, and that's a good vocabulary word, Natasha. Extrapolation is predicting outside of the range of the data that the model was built on. So if you built your model on numbers between 0 and 36, then we should only use it for predictions around those numbers, not predictions for 60 inches or, dropping the ball off the roof of the building, right? Okay. What if, I'm going to use your ball and I'm going to use your model and I'm going to drop it from 20 inches, so it's between 0 and 36, but I'm going to drop it on the carpet? No. So when you create a model, that model is good for very specific prediction purposes, and using that model to predict outside of those purposes is usually a bad idea. Okay? Okay, thanks everybody. Okay, so I talked about R squared and R and A. What was B?
The y-intercept.
The y-intercept. And what does the y-intercept mean in a line?
When x equals 0 is the y value.
Right, it's the y value for when x equals 0. So what would we kind of expect that y value to be for this particular model?
0.
0, because if I drop a ball from 0 height, that means I'm not really dropping it, I'm just sort of setting it on the ground, right? So I would expect that y-intercept should be 0. Was it 0? No. Well, that's something that you would have to deal with in our semester-long course on regression that you can all sign up for, okay?